Hey, my name is Brandon Gracely. I'm a high school math teacher, and today we're going to talk about where the quadratic formula comes from. The quadratic formula is this. X is negative b plus or minus the square root of b squared minus 4ac, and all that is divided by 2a. And this is in the context of a parabola which has this form. This is where the a's and b's and c's come from. Ax squared plus bx plus c. We call this standard form. That a can't be 0, otherwise that term goes away and you have a line or something even smaller. So we are going to take this form right here, the standard form, and we're going to rearrange it until we get this. But the quadratic formula is used when we want to find out the roots, or we sometimes call those the zeros, or the x-intercepts for a quadratic function. So on a graph, you might have something like this. Parabola goes through in a couple of places, and the quadratic formula is used to find out the x value of these two places. Maybe this one's like 3, 0, and this one is, well, on my graph it looks like about 5.50. When you have an equation that gives you sort of unnice numbers, things that have fractions or decimals in them, or even square roots, the quadratic formula lets you find those even when it's hard to factor. So our basic plan is we're going to rearrange this formula by completing the square, take a square root of both sides, and that's how we're going to get this nice function up here. So let's start by rewriting our standard form equation, ax squared plus bx plus c, and this time we're going to set it equal to 0. That's when the roots happen. That's what roots are. So let's start by completing the square here. Actually, first we're going to get rid of this a. The way I like to complete the square is by getting rid of this a value out here so that I don't have to deal with it anymore. So I'm going to divide both sides of the equation by a, which means every term on this side is divided by a, giving me x squared plus b over a times x plus c over a. And that equals 0 divided by a, which is still just 0. So I've divided by a, or you might like to multiply by 1 over a, whatever you like. Now I'm going to complete the square. So completing the square uses these two pieces right here. We're going to ignore the c over a bit. And what we're going to do, we're going to end up with an x plus or minus some number, and that whole thing will be squared. And we want this middle part to work out. So look back, if you like, at my video on completing the square. I'm going to, what we're going to do is take half of this number and square it, and then add it here. So b over, half of this number will be b over 2a. That's half as much as this one. That value is going to be squared. And we're also going to subtract that same number so we're not modifying our equation. And we still have a plus c over a. Sorry, these equal signs aren't lining up very well. All right, so I've added in and subtracted in that expression right there, because this part is going to be a nice square. So I have x, it'll be x plus b over 2a. That is squared. That's what this is right here. Okay, and if you expand this out, binomial expansion, you'll see that you get exactly that back. And then I have minus, I have some choices here. I can either square this and expand it out, or I can leave it like this. I think I'll square it. We'll go from there. B squared over 2a squared is 4a squared plus c over a equals 0. Okay, I'm just going to leave this alone, but I'm going to move stuff over to the other side here so that I can work with that. So on this side I've got x plus b over 2a. That's squared. As I move this stuff, or subtract it from both sides, I end up with b squared over 4a squared minus c over a. Okay, still leaving this side alone. Over here, I don't have a common denominator. This denominator here is just a. This one's 4a squared, so I need a 4 and another a to make these to have a common denominator. Sorry. And so I will be multiplying this whole term, top and bottom, by 4a. So here I've got 4a times c, and this is now I'm dividing by 4a squared. That's 4a on the top and 4a times this a on the bottom. Okay, we're kind of ready. We're just about there. I'm going to, one more thing I suppose just to make this a little cleaner. This side here, because these have the same denominator, I can put them together. B squared minus 4ac, and that's all divided by 4a squared. You might be seeing some things you recognize here now. Okay, so I'm going to take the square root of both sides. So the square root of this side is going to be x plus b over 2a. And this side is going to be a giant square root sign with all this stuff under it, b squared minus 4ac over 4a squared. But when I take the square root of this thing, this squared thing, inside of here, it could be a positive value, or it could be a negative value. And so this thing inside of here could be plus or minus this giant square root. So now I have x, I'm going to move this to the other side. I've got x by itself now, negative b over 2a, plus or minus square root of b squared minus 4ac divided by the square root of 4a squared. So I broke this into, instead of just taking the square root of the whole thing, I took the square root of the top and the square root of the bottom, and you're allowed to do that. We're almost there. X is negative b over 2a, plus or minus, well, the top is the root of b squared minus 4ac, and the bottom is, well, square root of 4 is 2, square root of a squared is a, so I have 2a. This is actually a plus or minus a, but we have a plus or minus right there, and plus or minuses just switch each other around, so it's actually fine to leave it like this. Okay, and now take a look. I have 2a on the bottom of both of those, so we will often combine those into a single giant expression. There's the two numerators, and the whole thing is divided by 2a. And that is your quadratic formula. That's where it comes from. Hope that was good. Thanks.